Hi class, today we're starting Unit 3, which is Chapter 4, and we're going to do Sections 1 and 2 together, classifying triangles. So our objectives are going to be to identify and classify triangles by angle measures, to identify and classify triangles by side measures. We're going to apply the triangle sum theorem, and we're going to apply the exterior angle theorem. So let's first talk about just some descriptors about triangles. When we name triangles, we're going to use this little triangle so that we show that we're naming a triangle, and then we're just going to name it by its 3 vertexes or its 3 corner letters. Okay, we have sides, and so sides, these sides are segments. So we're going to have segment AB from here to here. We're going to have segment BC, which is from here to here, and then our last one, which is segment CA from here to here. Then we have some angles here that we're going to label. And so we're going to have angle BAC, so angle BAC, or we can name it just by its vertex of angle A. Another one we have is BCA. So angle BCA, or we can name it again just by its vertex of C. And then our last, excuse me, our last one we have is ABC, or we can name it by angle B. So angle ABC, or we can name it angle B. All right, so that just gets out of the way some naming properties. Next, let's get into classification of our triangles by angles. If we look at our first triangle we have here, all of those angles we notice are acute. So we call this acute triangle, and it has 3 acute angles. If we look at our next triangle, and if I fill these in here for you, you remember that those mean congruent, then this one has 3 congruent angles. And if we look really closely, those are 3 congruent acute angles. And we call this one an equiangular triangle. Oh, there's an I in there. Angular. All right, equiangular. That's quite a mouthful. Then our next one we look here, we notice that one of our angles is obtuse. So this one here. So obtuse is our classification type, and it's done by one obtuse angle. And we know that it's only one obtuse angle, and we're going to see why in our next slide. All right, then here, if I put in this marking here, then that's a right angle, so that makes this a right triangle, and that's classified by one right angle. And I'm going to, again, like I said, on those last two, those two we know are going to be smaller. They're going to be acute angles. And we're going to see why here with our triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So the triangle measures are 180 degrees. If we think back to our obtuse and our right angles, if one of those is 90 degrees or larger, that for sure means that our other 2 angles are going to be smaller than 90, so that makes them acute. All right, so let's go ahead and name this triangle here. It's triangle ABC. Again, we're naming it by its corners, its vertex. And let's classify this. We have one angle that's 25, one that's 100, and one unknown one, but we know that the one angle that's 100 is obtuse. And so we only need one obtuse angle to classify this an obtuse triangle. All right, so we're going to use our triangle sum theorem to find out what x equals. We know that all 3 of those angles add up to 180. So if we take the 180 and minus our 100 and minus our 25, that's going to tell us what our x is. And that's going to tell us that x ends up being 55 degrees. All right. So now let's talk about our triangle sum corollaries, and this is going to go ahead and relate back to that triangle sum theorem. The acute angles of a right triangle are complementary, and we know this because if the whole triangle is equal to 180 degrees, if the C is equal to 90, then the measure of angle A plus the measure of angle B has to be blank. Well, let's figure that out. If they all equal 180, and we take out that 90 from our C, that leaves our A and our B left, and that's going to be 90. So 90 degrees. If we have one right angle, we know the other two add up to 90. All right, let's put some of this knowledge to use here and do some measurements and some labeling. So what type of triangle is DGK? So DGK, and I notice right away I have that right angle in there, so this is going to be a right triangle. All right, I want you guys to classify what type of triangle GKF is. So I'll outline it for you, G, K, and F. So go ahead and I want you to classify that by its angle measures. All right, let's go ahead together and find the measure of angle G or DGK. So DGK. So I'm looking for this angle in here. Well, I know two of my angle measurements for my triangle, and so I know that all three of them add up to 180. So let's take the 180 minus the 90, or that right angle, and the other 40, and that leaves our measurement to be 50. So that angle here is 50 degrees. And if I add up all three of those, they should equal 180 to do my triangle sum theorem. All right, I want you guys to try and find the measure of let's do the next one together. Find the measure of EKF. So let's see, EKF. So if we look here, we only know one measurement in that triangle, but we do see we have a special relationship there. Those three angles come together and make a straight line, and we know that straight lines are supplementary. So supplementary is 180 degrees. So let's minus out the 65 and minus out the 40, and that's going to leave us with EKF. So EKF, when we subtract those out, ends up being 75 degrees. All right, good. So now the next measurement is to find the measure of angle KGF. So KGF. Well, the measure of KGF, I want you to look at this one. There is a special relationship with some parallel lines and transversal. We have parallel lines with here, and we have a transversal that cuts through there. So take some time and think about that and try and figure out what my missing angle down here is. Once you have that, then you're going to be able to do number 6, which is find the measure of KFG. All right, so come with those two done for tomorrow, and we'll talk about those. All right, so next, let's use this next figure to answer some of these questions here. We'll do a couple together, and I'll have you guys do one on your own. Find the measure of angle 1. Well, if we look here, angle 1 is right here. Again, I know these two angles, so just finding the third one. And so all three angles add up to 180. So I just have to easily subtract my 85 and my 40, and what's left over is 55 degrees, and that's my angle 1. All right, find the measure of angle 2. Well, you guys have seen angle 1 and angle 2. Those are vertical angles that are across from each other. So you should be able to come and tell me what the vertical angle measurement is. So have that done. And then, look here, we have our triangle. We'll know 2 of the 3 measures once you find 2, so you can do 3 on your own. All right, let's learn another theorem. It's the exterior angle theorem. And what the exterior angle theorem states is the measure of an exterior angle of a triangle, exterior, remember, is on the outside, is equal to the sum of the measures of the 2 remote interior angles. Whew, remote. That means they're farther away from that outside angle. And interior, they're inside the triangle. So measures of angle 1, or a measure of angle A plus the measure of angle B, so again, we're just labeling them by their vertex, is equal to the measure of angle 1. So that's saying that this one out here and this one here, when we add those together, they're going to equal the same thing there. So then we can look at our relationship between these two angles. Another thing we'll know is if we have angle 1 and we add it to angle C, those two make a straight line. Straight lines are, think about it, think about it, think about it, supplementary, which is 180 degrees. All right, let's put this into practice here and look at this problem. Find the value of x Then find the measure of angle SNB. All right, well, we see two x's here, and one's on the interior and one's on the exterior. So we're going to use our exterior angle theorem. We're going to take and add our interior angles. So 50 plus x, and we're going to set it equal to our exterior angle, 2x minus 15. We do some magic, move some terms around. We get x equals 65. So 65 goes in there. Let's put it into our picture. And then the next problem says find the measure of angle SNB. SNB. So you're finding this measure here. We know two of the angles. You got to find the third. We know that they add up to 180. So go ahead and find that for me for tomorrow. All right. We're almost there, ladies and gentlemen. Classification of triangles by sides. All right, we see here we have those little hash marks. Those little hash marks, remember, mean congruent. So this type of a triangle we start off here with is an isosceles. An isosceles has two congruent sides. All right, then we see three hash marks here. So that makes it this is an equilateral triangle because all three sides are equal. They are congruent. So three congruent sides. All right, and then we look at the last one, and none of them have hash marks to represent that they're congruent. So we call this one scalene. It's kind of a fun word to say, scalene. And these have no congruent sides. All right, so we have those three by classification. So I want you guys to take a look at our last two problems here. Give them a go, and then tomorrow we will take a look at these. So see you then.